Graphs of exponential and logarithmic functions. An exponential function is going to be written in the form f of x equal to b to the x, where b is going to be our base and it'll just be a constant number, and x is going to be our variable. So the exponent is where you would substitute in values for the x coordinate if you wanted to find the y coordinates. Now for exponential growth and decay, growth is going to show a graph from left to right that is going to increase. And so that's represented when b, that base, is going to be greater than 1. Exponential decay on a graph, it'll show that it'll decrease as we follow it from left to right. And the b is going to be between 0 and 1. So you can tell just by looking at the equation whether it's an exponential growth or decay, or you'll also be able to look at the picture of the graph. Now when we're graphing these, we're really going to utilize either the graphing calculator or Desmos. And remember our transformations that we discussed before. So that letter A, H, and K in either growth or decay. If it's a negative A, it reflects over the x-axis. The number that A is will determine whether we stretch or shrink vertically. H is the horizontal shift, and remember, it's always going to be opposite of the sign that it looks like in there. And K is going to be our vertical shift up and down. The other thing is, in our exponential function, we have a horizontal asymptote at y equals 0. So when you have a vertical shift, it's also going to move your horizontal asymptote. So let's go ahead and look at this example, identify all the transformations, graph the function, and state all the information below. So we're told that y equals 3 to the x is our parent function. So I'm just going to highlight 3 to the x so that we know which numbers are going to contribute to our transformations. So if this is our parent function, we have a 2 multiplied out front. Now that 2 is going to give us a vertical stretch by 2. Since that number is bigger than 1, it's going to stretch our graph vertically. Now this last one, this is our vertical shift, and this is going to go down 4 because it says negative 4. Now once we identify that, our vertical shift is actually going to affect our horizontal asymptote. So our horizontal asymptote is going to be y equals negative 4. And you can go ahead and at negative 4, we can draw a horizontal asymptote. So that'll be our dotted line right there. Now when we're trying to determine whether our function is going to show a growth or decay, we have to look at that base. So the base is 3, which is greater than 1, so we're going to have a growth function. Now for the x and y intercept, we're going to utilize the calculator. So either use your graphing calculator or Desmos to graph the function, and then you'll find your x-intercept is 0.63, 0, and your y-intercept is 0, -2. Now those are the 2 points that I want you to plot on your graph. So we're going to estimate 0.63, that'll be around here for the x-intercept, and our y-intercept will be here. Now it's really important that we do identify this as a growth because that's going to help us graph our function. Your calculator or Desmos will give you a good sketch of how this will look, but our points are above our asymptote, so we're going to be here, and our growth, it needs to go upwards. So we're going to follow along that asymptote, and then this is going to shoot upwards for our growth. Okay. So remember, it's never going to touch or cross that asymptote, but it is going to cross our x and y intercepts there. Now when we get to our end behavior, as x approaches negative infinity, so over on the negative infinity side, as we go to the left, our graph is going to get closer and closer to this asymptote, but it's not going to touch. So our end behavior over here, it's going towards the asymptote at -4. As x approaches positive infinity on the very right side of our graph is shooting upwards, so f of x is going towards positive infinity. Lastly, when we talk about domain and range, our domain is our x-coordinate, so this is going to go left and right forever. So we can say all real numbers. In our range, we're going to have every y value above the asymptote represented, but no points at the asymptote or below it. So we say all real numbers where y is going to be greater than -4. So that means every y coordinate bigger than -4 will be represented by our graph. Now, if you felt comfortable with that one, I want you to go ahead and pause, try this example on your own, and check back with me when you're finished. If you don't feel comfortable, stay with me and we'll walk through this together. So remember, our very first step is going to be to identify our parent function. So we have 1/2 as our base and x is our exponent. So I'm going to highlight that in our function so that we don't address that. Now, anything that's not highlighted is going to contribute to the transformations on our parent function. So let's go ahead and identify those. This negative is going to give us a reflection over the x-axis. And then this +2 up here, remember, the number that is with the x moves the x, so this is going to be our horizontal shift. It says +2, which makes you think right, but it needs to be in the opposite direction, so we're going to go left 2. Now, because we don't have a vertical shift at the end of our function, that means our horizontal asymptote is just going to be y = 0. And then when we look at our base, this number is between 0 and 1, so this is going to be a decay graph. Now, when we go ahead and plot our horizontal asymptote, remember, this is right at our x-axis. So you want to be a little careful. If you need to plot it just above it to make sure that it's visible, make sure you do that. And using whatever graphing method you want, we are going to find our x and y intercept. So our x-intercept, because we have an asymptote on the x-axis, we actually will not have an x-intercept. And our y-intercept is going to be 0, -0.25. So I'm going to go ahead and plot that. 0, -0.25 will be somewhere between 0 and -1. Now, we said that this was going to be a decay, which meant that as we move from left to right, our graph should be decreasing, except because of this reflection, it's going to reflect over the x-axis. So our sketch will actually look something like this. So we're going to be following that asymptote on this side. So to help me sketch, I'm just going to draw it this way. So this is actually going to be the sketch of our function. Now let's talk about end behavior. As x approaches -infinity on the left side of our graph, our function is going down towards -infinity. And then as x approaches +infinity on the right side, we're going to get closer and closer to that asymptote. So our function is getting closer to 0. For the domain, again, this is going to keep going left and right as far as possible, so it's all real numbers. In our range, it's going from -infinity all the way up to, but not including our asymptote. So we're going to write this as all real numbers where y is less than 0. So any y value smaller than 0 will be represented by our function. Hopefully you got at least some of those answers right. Next, let's go ahead and take a look at the logarithm graph. A logarithmic function is the inverse of an exponential function. So there are going to be elements that seem similar but opposite to what we were just talking about. We're going to focus on the parent function, f of x equals log base 10 of x. So there's a little invisible 10 that sits there. So on the calculator and graphing, we're only going to focus on base 10. Now, an exponential function had a horizontal asymptote at y = 0. So our logarithm function is going to have a vertical asymptote at x = 0. So here we have our dotted asymptote at the y-axis. Now, because of that asymptote, we do not have a y-intercept, but our x-intercept is at 1, 0. So this is our parent function, remember? This is what it's going to look like. So again, just like the exponential, it's going to hug the side of the asymptote and then it'll veer off and shoot out. Now this is going to keep going out towards positive infinity to the right and upwards. It's just going to slowly keep going. Now the domain of our function is from 0 to positive infinity. So from the asymptote, all of the x values that are going towards infinity is going to be part of our domain. We can write that as all real numbers where x is greater than 0. Now for our range, we're going to go down forever, and like I said, this is going to keep going up slowly, but it'll keep going forever. So our range is from negative to positive infinity, or we can represent that as all real numbers. Now our end behavior is going to be a little different as x approaches 0. So remember, because our x values don't go towards negative infinity, they're going to be stopped here by that asymptote. So as our x values are getting closer to that asymptote at 0, our values are going to go down towards negative infinity. And then as x approaches positive infinity on the right side of our graph, we're going to go to the right, but we're going upwards slowly. It will go towards positive infinity. Now that we've discussed the parent function of the log graph, let's go ahead and look at all of the transformations. So we have the same letters, a multiplied in front of the log, h is inside the parentheses with the x, and k is at the end. So just like the exponential, we're going to utilize our graphing calculator or Desmos to help us graph our function. Negative a tells us we're reflecting over the x-axis. The number a is going to help us stretch or shrink vertically. H is going to be our horizontal shift, and it's going to move our graph left or right in the opposite direction, but this is also going to move our vertical asymptote. And then k is going to shift our graph vertically up and down. So we're going to walk through similar steps, identifying the transformations, graphing the function, and filling out our information below. So remember, our parent function is log base 10 of x. So this is our parent graph, and we have to identify all of the remaining transformations. So this number multiplied out front, 1/2. This is smaller than 1, so this is going to be a vertical shrink or compression by 1. And then this number, remember, the one with the x moves the x in the opposite direction, so this is going to be a horizontal shift to the right 3. And again, this is going to affect our vertical asymptote. So we get x equals 3. So we can go ahead and plot our vertical asymptote at positive 3. Here's our dotted line going up and down for our vertical asymptote. Now, when you use your calculator or Desmos to find your x and y intercept, you'll find that the x-intercept is 4, 0, and that you have no y-intercept. So this is going to be our x-intercept, and so we're staying on the right side of that asymptote, so our graph is never going to cross over to actually hit the x-axis, which is why we don't have a y-intercept. So once you plot this point, if you use your calculator or Desmos to help you, this is going to be a sketch of our graph. So as x approaches what number is f of x going towards negative infinity? So this is set up a little differently, but our function is going towards negative infinity as the x values get closer and closer to that vertical asymptote. So as x approaches 3, f of x is going to negative infinity, and as x approaches positive infinity on the right side of our graph, f of x is going slowly up towards positive infinity. And so again, our domain is going to be all real numbers, but they're only going to be on the right side of this asymptote, so it's going to be where x is greater than 3. And then our range, we're going down forever and up forever, so it's going to be all real numbers, which is the same as negative to positive infinity. Now again, hopefully you feel much more comfortable answering these questions, so I want you to try to pause, try this example on your own, and check back with me when you're finished. And if you don't feel comfortable, just stay with me and we'll walk through this together. So again, let's identify our parent function, and then we need to identify all of the transformations after that. So this negative out in front is going to give us a reflection over the x-axis. And then this 2 at the end, this is going to be our vertical shift, the same sign as you see, so it's going to go up 2. Now, because we don't have a horizontal shift in here, our vertical asymptote is just going to be x equals 0. So let's go ahead and plot our vertical asymptote. It's going to be right on that y-axis. Remember, if you need to put it a little to the side so it's more visible, then make sure you do that. And then go ahead and use your calculator or Desmos to find your x and y intercept. Our x-intercept is going to be 10, 0, and our y-intercept is actually none. It doesn't exist. So this time, because we have a vertical asymptote right on the y-axis, we're not going to have a y-intercept. So if we go ahead and plot our x-intercept, I know it's a little off our graph, but I'm just going to put it here just to help sketch. Now, when we do finish off the sketch, usually it goes towards the asymptote and goes down. But because we have a reflection over the x-axis, we're actually, from this point, we're actually going to go up towards the asymptote at the top, towards positive infinity. So your calculator or Desmos is going to help you sketch that. Now, as we complete the end behavior, as x approaches what, does f of x go towards positive infinity? So again, this is going to be our asymptote, because as our x coordinate gets closer to 0, our graph will shoot up towards positive infinity. And then as x approaches positive infinity, our y values are going to keep going down slowly to negative infinity. And then again, our domain is the one that's restricted by our vertical asymptote. So we're going to have all real numbers where x is greater than 0, everything to the right side of our asymptote, and our range, everything from positive infinity all the way down to negative. So we're going to put all real numbers there. Now that's it for these examples. I'll see you in class for more practice.